Hello everyone, I welcome you all for SVK tutorials. In this session, I am going to discuss the scheme and solution for the model question paper SET-1, which is for 2022 scheme with the subject title Discrete Mathematical Structures with the subject code BCS405A. So this has been given as a elective paper. So you'll be having different codes here. So I am discussing only BCS405A. So in that I am taking module 1. So in module 1, question 1A, you can observe that they have been asked to show that the compound proposition, they have been given the compound proposition for primitive statement PQR is logically equivalent. So we need to prove that the given compound proposition, I can name this as left hand side and this is right hand side. These two are logically equivalent, we need to prove. So which is nothing but P biconditional Q in general. I am saying that P biconditional. If you think that this one compound proposition is P, biconditional Q is tautology, then we can say that it is logically equivalence. Now let us see the solution. So go to the solution. See here. So I have been constructed the table here. So you can see the table here. As they have been asked for to prove that it is logically equivalence. So as we know that it has been given 3 primitive propositions. So for that reason I have constructed the PQR. So you need to know that how many truth values you need to create. So as we have 3 primitive propositions, so you need to raise 2 power 3, which is equal to 8 truth values you need to have. So for 3 primitive proposition PQR, I have taken the truth values here. For P, 4 truths and 4 false. Similarly for Q, first 2 truths and that is true is nothing but 1. 0 is nothing but false here. So false, false, true, true, false, false. Similarly for R, I have considered 1, 0. That is true, false, true, false, true, false. Then what is the thing they have been provided? You need to know that. So I'm going with simple compound proposition first. That is P biconditional Q. You know the definition of P biconditional Q. If both are true and if both the primitive propositions are false, then it is true. That is what I have written here. If P and Q are true, I have written true. If P and Q are false, I have written true. So first I will go with that part. Wherever I have been there with true, true and false, false, I have named that as true, true. Rest of the values are false. Similarly, I will do the case for Q biconditional R. That is what I have got here. True, true, true. For what reason? Since we are going to observe that Q and R will be having same truth values, for that reason you are going to have 1, 1 there. So similarly for R biconditional P, so I am constructed first true, then the remaining truth values will be false. So likewise, these are the 3 simple compound proposition we are having in the left hand side. And these simple compound propositions are by connected with the conjunction. So for that reason, I have named these columns by 1, 2, 3. Then I have taken column 4 as 1 conjunction 2 conjunction 3. You know the definition of conjunction. So if both are true, then it is true. Otherwise it is false. If I go with the 1 conjunction 2, that is 1, this column 1 conjunction 2, 1 conjunction 1 is always true. So that you are left out with the true. True conjunction again column 3 true. That's why it is true here. So when I go with the 1 conjunction 2, as here true false, we have true false is what? False. So false conjunction with false is again false. Therefore that is what I have mentioned here 0. So likewise when I observe the last row, I have got the 1 there. Since all the truth values are 1, that's why it has been 1. So the remaining truth values will be 0, since there is a possibility of getting 1, 0. 1 conjunction 0 is always 0, or 0 conjunction 0 is always 0. So for that reason, I have constructed a 0. That is what column number 4. So when I come to column number 5, similarly, when I observe the right hand side of the logical equivalence, so I have the simple compound proposition as P implies Q. You need to know the conditional truth value. When we say that what is the truth value for conditional, if P is true and Q is false, it is false. That is what I have done here. If P is true and Q is false, then P implies Q is false. Wherever I observe P is true and Q is false, I have put false. Rest of the cases are true. I have done that part. Similarly, I will go with Q implies R. So here also I have been observed that wherever I have Q is true and R is false, I have made that as false. The rest of the values are true. Similarly, I will go with R as true and T as false. So that is what I have made that as false. The rest of the values are true. So similarly, in the right hand side, all these 3 columns has been connected by what? Conjunction 5, conjunction 6, conjunction 7. I have named that as column 8. So what is the definition? So wherever I observe 1, conjunction 1, I am going with 1. So similarly, in last row, I am going with 1. Rest of the values are 0. The reason behind that is, if we observe 1 conjunction 0, conjunction 1 is always false itself. That's why I have named the remaining truth values as false. So when I observe column number 4 and column number 8, if I go with logical equivalent, both the columns are same, one and the same. So therefore I can get the truth values as what? True. I can say that it is a tautology. Therefore, once we came to know that it is logically equivalence, we can say that the given compound propositions are logically equivalence. So if you give this way answer, it will be given as full marks. It will be awarded full marks. When I go with the next problem, so you can see the next problem. So the next problem has been given. Establish the validity of the following argument using the rules of inference. So they have been mentioned by rules of inference. You need to establish this argument. So whatever the given argument has been given here as a compound proposition, by using the connectives called conjunction. You know that the rules of inference always be connected with what? Conjunction. And you need to give the conclusion. That is what the conclusion here. This is what the conclusion. Yes, disjunction T I need to prove. So to prove that part, I have gone with the rule of inference. You can see the answer here. So whatever compound propositions I have taken here, the compound propositions are P implies Q, yes, disjunction R implies negation Q. So by using, therefore I need to give the conclusion as what? Yes, disjunction T. So first I will consider in this rule of inference, I have how many compound propositions I have? 4. Out of these 4, I will consider 3 and 4. So when I consider 3 and 4, I will apply condition law for step number 3. Yes, disjunction R is nothing but, you know that negation of condition, P disjunction Q is logically equivalent to, we can write this as negation P implies Q. So using this law, I can write that yes, disjunction R as negation yes implies R. And I have retained the fourth one as it is. Then I will apply rule of syllogism. So you know that rule of syllogism is what? P implies Q. You know that P implies Q. Q implies R is nothing but what? P implies R. This is what rule of syllogism. So using that rule of syllogism, I have written that negation yes implies negation Q. I got from step number 3 and 4 as what? The conclusion. Negation yes implies negation Q. So this can be written by using rule of contrapositive. So we know that inverse, converse, contrapositive for condition proposition. If we have any condition proposition, we can apply contrapositive. So for that contrapositive, since it is logically equivalent, so I can write this as what? Negation yes implies negation Q can be written as Q implies yes. That is what I have written by using contrapositive. So therefore I will consider 2 and this, whatever the conclusion I got. So step number 2 is what? P implies Q and Q implies yes. from rule of syllogism, again I can write that as what? P implies yes. That is what the conclusion I can come. So then I have left out with step number 1, that is P. So P with P implies yes is finally yes by modus ponens rule. By using rule of modus ponens, we can write that as what? Yes. So finally, by disjunctive amplification, we can write yes disjunction T. Since we know that yes disjunction T is nothing but yes itself, as I need the conclusion with yes disjunction T, as I have proved that part, and hence it has been proved. If you have proved this in this way, it will be carried with 7 marks. Moving with question number 1C. Coming to question number 1C. So the problem 1C is of quantifiers. They have given the question. It has been well defined. P of x, Q of x, R of x, S of x, T of x has been defined here. So using this definition, predefined quantified statements, using this quantified statements, we need to write the symbolic form for the statements here. So statement 1 says that at least, for at least, how to write the symbol you need to know. At least there exist, you know that symbol, this is the symbol. For all you know, or for some you know, this is the symbol we are going to use. Using these category of way of expressing the symbol, we will express the given problem in terms of symbol. Going to the solution part, here question number 1C, I have given the solution. So they have been asked at least, therefore, so I have written here, there exists x, Q of x. That is what the solution for the first one. Since what they have been provided, you need to know. So the given question was what? The given question is at least one integer is even. Here Q of x is defined as what? X is an even. That's why, therefore, at least one integer is even means is nothing but what? There exists Q of x. Similarly, if I go with next problem, there exists x, P of x conjunction Q of x. Similarly, for third one, the symbol form is for all x, Q of x implies negation S of x. Since they have been given there, not. They will mention not there. That's why. So when I come to the question number 4, make a correction here. The answer is given by negation Q of x implies T of x. It is not conjunction. It is implies, not conjunction. So the question number for the question number 5. So there exists x, Q of x conjunction S of x. That will be the solution. So this is what question number 1. So now we will see the question number that is question number 2. So they have been asked, question number 2A has been asked as a define tautology. Prove that for any proposition PQR, the compound proposition, whatever the given compound proposition is tautology I need to prove. So what is given here? P implies Q, conjunction Q implies R. This whole implies P implies R is tautology I need to prove. First define tautology. Then after defining tautology, we can prove this by constructing the table. So everyone need to know the definitions here. So the definition of tautology has been defined here. Also they can give a contradiction also. Definition of contradiction. A compound proposition which is true for all possible truth values of its components is called a tautology. After defining this definition, we will go with constructing the table. As the given compound proposition contains P, Q, R. So I told you how many truth values you need to consider. Since we have 3 primitive proposition, it should be 2 power 3. So it is 8 truth values. That is what I have constructed here. Then I will go with the column 1 as P implies Q. I will find out P implies Q. As I explained the condition proposition, you can make use of that definition. Similarly, I will find out Q implies R. Then I will go with conjunction between column 1 and column 2. That is what I have done. So conjunction 1, 1 is 1. Wherever I will observe 1, 1, I have made that as 1, 1. So these are all 1, 1. Then the remaining part are 0. The remaining truth values are 0. Next, I need to find out P implies R. I will find out P implies R and I will name that column as 4. That is what I have done. Wherever I observe 1, 0, 1, 0, I have made that as 0. 1, 0, I have made that as 0. Rest of the values are 1. Finally, I will go with 3 implies 4. Since you know that The given problem was like this: P implies Q conjunction Q implies R. This whole compound proposition implies P implies R. That is what we are doing. Now this is what 1 conjunction 2 we have done, and finally I named this as 3. 3 implies 4 I am seeing. So therefore column 3 and column 4 implies what? So you know that implies definition 1 0. Wherever you find out 1 0, that will be 0. The rest of the values are 1. That is what I have made here. Since I didn't observe 1 0, so therefore the values, the truth values I got here 1. So when I observe the last column, I can say that the given compound proposition is a tautology. So moving to question number 2b, prove the following using laws of logic. They have given a compound proposition. So we need to consider the left hand side. I need to come with the right hand side by using laws of logic. The choice question was similar, but using the construction of table, we need to prove their logical equivalence. Without table, by using the laws of logic, we need to construct that it is logically equivalence. That is what they have been provided. If you do here, when they are mentioned specifically using laws of logic, if you go with the construction of table, there is no marks will be awarded for that cases. Make a note of it. So as I need to show that the given compound proposition is logically equivalent to another, so I have considered P implies of Q implies R. First, I will go with by negation of conditional. So I can write Q implies R can be written as what? I can write Q implies R as negation Q disjunction R. That is what I have written. First I have taken that negation Q disjunction R. Next, again I observe that you can think that this will be some proposition called K or whatever, or Q or something. So P implies Q, like that. Since we know that P implies Q can be written as what? Negation P disjunction Q. That is what I have written. By negation of the conditional, I have done negation P disjunction of negation Q disjunction R. As I observe in this compound proposition, both having disjunction with a bracket, so I will go with change of bracket. That is what called associative law. I have applied associative law. I have changed the bracket. Then I will go with De Morgan's law. I will apply De Morgan's law. De Morgan's law says that when we have negation P disjunction negation Q, I can write that as negation of P conjunction Q disjunction R. So again I will go with negation of condition. Says that what? If we have negation P disjunction R is logically equivalent to what? P implies R. P implies R. That is what I am writing here. So I have here negation of P conjunction Q. So P conjunction Q implies R. So that is what I needed to prove, and proved that part. Therefore I can say that these two are logically equivalent by using laws of logic. So moving to question number 2c. So the question number 2c is given like this: given or give direct proof, indirect proof, proof by contradiction for the following statement. They have provided the statement. You need to give a direct proof, indirect proof, and proof by contradiction for the given statement. What is the given statement? If n is an odd integer, if n is an odd integer, I will name that as P, proposition P, and here then n plus 9 is an even integer, that is what? Q. So if P then Q means what? The given problem is of the form P implies Q. So using this P implies Q, I need to define direct proof, indirect proof, proof by contradiction. Let us go through the solution for this. Coming to direct proof, let n is an, we need to assume that n is an odd integer. For direct proof, we need to assume what? N is an odd integer. So we know the definition of odd numbers. 2k plus 1 is always what? Odd. So like that 2n plus 1 is also odd. Here n should be what? N is an odd integer. For that reason I have defined n is equal to 2r plus 1 for all r belongs to integer. Then what is given? N plus 9 is an even integer. They have been provided. So I need to prove that part. So I am going with that definition. I will consider n plus 9, which is equal to, what is n? I am assuming that n is an odd. So for that I am going with substitution, n equal to 2r plus 1 plus 9 as it is. So therefore plus 1 plus 9 becomes what? Plus 10. 2r plus 10. Taking 2 common, what I have left out? 2 times of r plus 5, which is equal to what? 2k. I can write k as what? R plus 5. So which is nothing but what? 2k is nothing but what? Even number. So which is even. Hence by direct proof, I have proved that by considering n as an odd integer, I have proved that n plus 9 is an even integer. Hence the direct proof has been concluded. Going with indirect proof, we assume that first we need to assume that negation q is true. That means what? Q is false. When negation q is true, q should be false. If negation q is false, q will be true. So I am assuming that negation q is true. Therefore q will be what? False. So you know what is q? Q is what? N plus 9 is an even integer. So as I am considering the negation of q, so therefore n plus 9 will be an odd integer. Since given q is what? Given q is even integer. They have given n plus 9 is even integer. I need to consider what? False statement. That is what I have considered. False statement means when it is not an even integer, it should be an odd integer. That is what I have taken. Converse of that part. So therefore, n plus 9 will be equal to what? 2r plus 1. So solving for n, what I am going to get? Let us see. So I have shifted this 9 to right hand side. So I got 2r plus 1 minus 9, which is equal to 2r minus 8. By simplifying 1 minus 8, which will be equal to 1 minus 9, which will be equal to minus 8. So therefore 2 times of taking common as 2, I got 2 times of r minus 4. So r minus 4 is some integer. So I have mentioned that as k. So I have left out with the 2 times of k, which is what? Even. Thus n is what? I got. Thus n is given. The problem is odd, but here I am getting as what? Even integer. So thus if n is odd, then n plus 9 is an even integer. Hence I have proved that indirect proof. In indirect proof, what I have considered? Converse of q as what? N plus 9 is an odd integer. I am proving with n is an even integer. But the given statement is what? N is an odd integer, then n plus 9 is an even integer. That was the given statement. So coming to proof of proof by contradiction, the last part of this, we are going to assume that P implies Q is false. That is what the way of proving by contradiction. I am going to assume that P implies Q is false. When it will be false, you know that if P is true and Q is false. If P is true and Q is false. For that reason, N I have retained as it is. N is odd and false statement of Q, you know that N plus 9 is odd. That is what I have written. So N is odd and N plus 9 is odd. I have written. Therefore, N plus 9 is equal to 2R plus 1. Since N plus 9 is odd, I have expressed that. Therefore, simplifying for N, I got N as what? 2K. 2K is what? Even, which is even. This is nothing but contradict for our assumption. It should be what? N should be odd here, but what I am getting? I am getting even integer. Therefore, it contradicts to our assumption. Therefore, we can say that this contradicts the assumption that P implies Q is true. Therefore, we can say that the given statement is what? If N is odd, then N plus 9 is an even integer. This is how we can solve the problems of fundamentals of logic from module 1. So you can score maximum marks, which is having 20 or 20 marks. If it is not possible, I have told you that in my previous video, you can score minimum of 13 marks. I told you to refer these two only, theorems of proofs. That is what one thing you need to go through, and tabulation problem. If you study these two, you can score 13 marks. Definitely you can score 13 marks. This is what from module 1 I have discussed the solution from SET-1, model question paper SET-1. So if you have been any doubts, you can put a comment. I will clear your doubts. And thank you all for watching this video. If you like this video, kindly do subscribe to my YouTube channel, and also do share this video with your friends. It may be helpful for someone else also. Thank you all for watching this video.